Hello and welcome to today's streaming. I'm happy to be here and I'm happy that you're here. What are we going to talk today? So maybe I just give a little summary of what we talked and what we did last time. I'm going to switch to my desktop because I actually have a little overview of what we'll cover today. But for those who have not followed the previous streamings, the only thing I'm going to tell you is that we are developing a web application and React, and later on there are more cool stuff coming. And what we have done so far is we have applied a lot of TDD principles to develop our components. We have talked about decoupling logic and presentation layers. We have done a lot of cool stuff. If you want to check it out, then make sure to check the previous streamings. Here is just an example of what we are doing. I'm not going to go too much into the details, but we are really trying to stay very focused on how the users will interact with our application and what are the resulting behaviors. And this is perhaps what you should focus on whenever you are developing a web app, is not really on the internals of the web app, but rather on the experience that your users will have when they are using it. Cool. So that being said, let me switch for today's agenda. And what we're going to do today is we're not going to work on the application, but wait, don't go away yet. We have done quite a bit with React, and some of the interactions of our components, they are quite not yet that complex, but they are getting there, or they will get there. Before we actually start developing more complex interactions, more complex compositions, it does make sense that we start, or that we have a look at how our components are actually, or how React works behind the scenes. And we'll also talk today about lifecycle methods. So the agenda, hopefully, I'm going to stay within the 1 hour and 15 minutes. I don't want to take too much of time to explain these things, because what I will explain today is a model of React, right? It's not really exactly how React works. If you go to the code, there is a lot more. But what we are interested here is in developing a mental model that we can use to understand how our actions, how the different components in the DOM, they will interact with each other, and how React will manage this whole thing, and how React will manage the updates, and exactly, so managing the components, so on and so forth. And then we talk about the life cycle of a React component. If you are somewhat familiar with class components, or if you've read a little bit about React, you know that there are certain methods or certain, let's say, steps that you can hook into, and you can leverage that. So for example, when the component is being mounted or has been mounted to the DOM, then you can run some functions there, or when the component has been unmounted from the DOM. So there is quite a lot of things that you can do with this logic, and this is what we will cover here. Okay, so it's a basic, so it's an introduction, but it will give us very nice groundwork, so very nice foundation, so that we can later on continue our development and really understand what is going on. I think what's really the important thing is to understand what is going on whenever you are developing a React app, and not just relying on guessing. I guess this is gonna work. I guess this is, let's say, performant. I guess this is how things should be done. No, you have to understand what is going on. And that's what I want to try to do today. Okay. With that being said, hi Sander. With that being said, let's have a look at our agenda for today. So first one is a model of React. We're going to go through what happens when we first open a React application. We'll also dig a little bit deeper into what are the main phases, what are the main stages of a React updating cycle. We will then discuss what triggers a re-render, and we'll enter into a more philosophical discussion of whether too many re-renders are bad or not so bad. And that is, of course, the answer is it depends on how many re-renders, but we want to understand what makes a re-render good and what makes a re-render bad. Okay, this is for the first part, and I think that once we finish this, we take a 5-minute break and then we can come back and talk about the life cycle of a React component. And although there are more elements to discuss here, there are 3 things that you really need to understand. The first one is when can you run a function, or what happens when an element is mounted into the DOM. The second one is when is an element or a component updated. And the third one is what happens when a component is unmounted from the DOM. Now for that, we're not going to use our example here, or we are not going to use our app, but we're going to use a cloud environment that I just set up for this, super basic. Just open this website if you want to create your own cloud sandbox. You can open this website and just set it up. There is a nice console here that you can use to print some messages. I think this will give everything we need in one screen, and I'm going to stick to this example. And I will also try to draw some stuff. Now I am not an artist, but I'm going to do my best to try to illustrate a couple of the principles here so that we can work well, or that we can illustrate a little bit the things that we will discuss. Okay, so let's start with a model of React. What happens when React first opens the application, right? So here you see that we have a couple of components, right? So actually this is just one component. So maybe we could add another component here. We're going to call this child component. Okay, yeah, that's a very broad name. You would do better than this, of course. And this will just return a div, which is going to print some stuff like child component to the screen, right? So super basic, nothing new here. And we're going to print this child component within an h1, okay? Or actually, we can print it outside. Let's just print it here with a child component like so, right? So now you can see that this is already up to date. I don't really like that it really keeps printing stuff here, but we have to live with that. The child component is rendered here, right? So first of all, when React opens the application, or when we first load our code, React will render everything for us. It will go through the whole tree, and it will render everything in the DOM. So in the end, what we get here is really a DOM tree. Now, what is a DOM tree? A DOM tree is really a tree. So a tree, think about a data structure tree, right? Which has, it's not binary, but it basically can have an arbitrary number of children per node. So you would have, where is it? Does it work? Aha, should work. Why isn't it working? Ah, there you go. Maybe some pressure. Yeah. So this would be the root node. And in our case here, that here would be the root node, right? The app node is the root node. And this app node has one child, which is the div child. So this could actually be the root node if you think of it. And this one has 3 children, right? It has, first one is an h1. First one is an h1. The second one is an h2. And the third one is the child component that we have. So that's the child component. Okay. Now, if the child component had other children, then this would also be rendered by React in this first scanning of the DOM, or when it first opens the application, right? Now, whenever React writes this down to the DOM, what React also does is it keeps a virtual copy of this DOM tree. So it keeps a virtual copy of this in memory, okay? And this is perhaps where things start to get a little bit different than what you would see with other libraries out there. For example, jQuery, right? I mean, jQuery is super old. Nobody else talks about, they talk about jQuery because some legacy applications need jQuery. But anyway, I wouldn't advise you to go down that road. I'm going to clean this up again. So what happens is that there will be, in our case here, there will be 2 different not instances, but two different versions of the DOM. So React, right? React's going to have a virtual DOM, which is mainly in memory, okay? And there will be a real DOM out there. Now this real DOM here is really what you're seeing on the screen. It's the actual DOM. And this here, it offers a quite slow read and write operation. So if we were to always operate in the DOM, then what would happen is that our application would inevitably become very slow. And we don't want that to happen. And React also knows that we don't want that to happen. So what React does is it works mainly with the virtual DOM. And then whenever there are changes to the virtual DOM, it writes these changes to the real DOM. Okay? It can identify when there are differences. Think about when you commit a code, right? When you commit a code, if I were to maybe, I could try to open here the diff. Let's see. Show diff, exactly. So here we have, this is not a good example because this has has only the main diff. So maybe this one here, I could actually show the diffs. So there you go. Here, this is a diff, right? This is a difference and it's done in Git. The principle is pretty much the same. This would be our state before a certain render. This would be our state after a certain render, if you think in React terms, right? This is all Git here, is nothing related to React, but I just want to show you the concept of a difference. This line has changed and has been substituted with this, and there was a new line added here, and two lines were actually kept the same, okay? So not everything changed, and we don't need to update everything every single time. We can also save and update just the diffs, just the changes. Now, that being said, let's have a look at what happens then once React, I don't know why this is not so, okay, I'm gonna get used to it. So let's have a look at the flow. Okay, so first of all here, let's imagine that we have a little DOM, right? And our DOM is going to have, let's say, just a set of basic components. And here then we would have, again, 2 components, and this would have 3 components. This would have 2 components, and then this one can have two children, okay? So here, this could be a div, this could be another div, this could be, I don't know, an article, or maybe this could be the root, this could be a header, this could be the menu, this could be the logo and the title, the text, or whatever you want to call it. The idea is that React will, at every iteration, we will have a look at in a little bit what is an iteration, at least from my perspective. And I think it makes sense. I remind you that this is my mental model of React. Okay, I did some research, I read a few things about the whole library, and this is the mental model I could come up with. So what happens is React is going to, whenever there is a re-render of a component, whenever a state of a component changes, so let's say here that we'll have an event here, and this is going to be a re-render event, okay? So this is just a re-render event. And now, let's say that the state of this component here, I'm just gonna change this, let's say that the state of this component here changed, and then React is going to come here and it will re-render this component. Now, a re-render of the parent component triggers the re-render of all its children components by default. So this component will be re-rendered, this component will be re-rendered, and this component will be re-rendered. Because this component has children and it has re-rendered, then this component will re-render and this component will re-render. This will not re-render, this will not, and this will also not. So there was this re-render event here. Now React is gonna ask, okay, now React is gonna ask after this event, and then we need to keep in mind that at the end of each of these re-renderings here, have a look at our code. at the end of our re-rendering, or at the end of our rendering, we have a return, right? This return here gives us some HTML that React uses to compare the virtual DOM version and the actual DOM version. So here we have, I'm gonna call the VDOM, and that's for the virtual DOM. And we have, so the VDOM, and React asks, is the virtual DOM different than the actual DOM? Is this the case? And then here we would use, oh, that's tough. I'm gonna try to do it better. I think I can do it better. Let's have a look. Let's see if I can maybe use some of the constructs. Ah, that looks better. Looks much better. Can I write some text? Yes. So is the VDOM different than the DOM? Right? So we are asking this question. Is the VDOM different than the DOM? And this is the first thing that React will ask. If it is the same, if they are different, then what's going to happen is that React will come here. So let's say I'm just going to put it here and I'm going to connect to. There you go. So in this case here is if yes, right? So here, if yes, then what React will do is it will write, so here, it will write the differences to the DOM. Okay, it will write the differences to the DOM, and then it will wait. And here maybe we could actually add a little, I don't know what's the symbol in this diagram, but could actually use this here, wait for event, or wait for whatever change in props. And we can connect this with this, right? And maybe, I don't know if I can carry, no. So we're gonna wait for the event, and here, if there was no, if the VDOM is actually equal to the actual DOM, right? So for this question, for this decision here, it's gonna be no. So we will then just wait for a new event. Okay, let me just delete this whole thing here, and I'm gonna make it look a little bit better. So now let's say that there was an event, right? There was a change in state triggered a re-render. Okay. So then after this here, now we're gonna have this little one connected to this one, and I could start maybe making a little bit of a different, let's say different colors, so that we can start playing around a little bit. And then here React will re-render all the affected components, and then it will ask again. So I'm gonna have something like this, and then it will ask again what happens. Okay, so this is a super simple mental model that helps me understand at least what is up. So I think I can zoom it in a little bit, and we can go again through this quite quickly. So you have your component sitting here in the DOM doing nothing, okay? And then suddenly a change in state of that component triggers a re-render. So what triggers a re-render, right? There are 3 elements here that can trigger a re-render. We will come back here to this in a bit. But one of these 3 things happens, and then React will look at the component that re-rendered, and it will re-render itself. So this component and also all the children of this component. Once this is done, React will look, and all of these re-renderings happen in the virtual DOM. Once the virtual DOM is completed with all the re-renders, then React is going to look, okay, is the virtual DOM different than the DOM that I know? So if there are differences, and then we would enter into the yes arrow here, then we will write the differences to the DOM, right? So here we could color maybe with a different color like this. If there are differences, then we're going to write these differences to the DOM. If there are no differences, then we will simply go and wait for the next event. So for example, here React is waiting. React doesn't have anything to do. and it's just waiting until an event triggers a re-render. And this, as you can imagine, this is a cycle, right? So this is pretty much the whole cycle of the application. There are, of course, many subtleties to this, but I don't think we need to enter into details here. What is important for us to know, and perhaps the most important part comes now, is what triggers a re-render, right? That is the next step that I want to talk about, and it is within this little rectangle here. So let me remove this horrible drawing. There you go. Go away. Also go away. Okay. So what triggers a re-render? There are three things that trigger a re-render. First one is a change in the component's state. Okay. And I'm gonna maybe write something here. And that's an interesting font. So what? I prefer the written one. There you go. So what triggers a re-render? And the first one is a change in the component's state. Okay, if a component changes its state, this triggers a re-render. The second thing that triggers a re-render, let me write down here. Second thing that triggers a re-render is the change in the component's props. Okay, if the props of the component change, then this will trigger a re-render of the component. And the third thing that causes a re-render is a re-render of the child. A re-render of the parent. A re-render of the parent component. Okay? So these are the three things that actually can cause a re-render in our application. I'm going to put them here. Do I have anything here? Maybe I could just use no and then no and just make it a little bit nicer, like so. That's the first one. And that's the second one. I don't know how to use that, but anyway. So this is what will cause a re-render on the component. This is what will trigger the execution of the function body, okay? And this, I think, is something important for us to understand. What is a re-render? I think that is the next natural question. And a re-render in React is simply an execution of this function body. That's a re-render, okay? So we have covered what triggers a re-render. And then we have the question, are too many re-renderers bad? And for this, I think we will start working a little bit with the application. Let's try to get an understanding of how this works in practice. I'm just gonna clean up stuff a little bit. There you go. That's much better. So we're gonna have a couple of console logs here, I think. Let me have a look. Console log. Can I console log a tab or? Let me see. Child re-rendered. Yes, I can console log a tab. That's very good. And then if I console log here on the parent component, and I'll just remove this and I'll say parent re-rendered. Okay, so now I can actually have a little bit better overview of the level of our actually, I could just create a little, let's say, print with tab, or we could even say pretty print, pretty console, right? And here we're gonna get a message. So a message is gonna be a string, and we're gonna get an indentation. Indentation is going to be a number, right? And then here, what we want to do is we want to say console log. We're going to have a little bit here, and we'll simply say, could actually make a let result, and the result is going to be an empty string. Now for const. I'm sorry, I'm not really paying any attention to any optimizations or whatever. There are for sure ways of making this better, but I'm just making it as straightforward as possible. While I is less than indentation, then I++. And here what I'm going to say is just result plus equals the character tab. Okay. And what is this complaining? Let, right? This should be let I. Then afterwards, so just have result plus equal, again an empty character, and the message. Yeah, that should be enough. And then I would like to console log the result. Okay, so quite straightforward. Let's have a look if we can actually substitute this here. Pretty console, child, component, and the indentation is going to be 1. Perfect. Seems to be working. Want to clean it up again. And let me have just a quick test, right? Just a quick test here. Just want to see what happens if I say 0, 1, 2. And okay, it's working fine. Nice. I'm just going to put this in our new file. Let me see if I can do that. Pretty console.ts, because otherwise we're going to start messing things up here, and we don't want to do that. So export const console, pretty console, and here then I can just import. Let's see if it's going to be supported. Not so sure, but pretty console from dot pretty console. Yep, works just fine. Perfect. So what we wanted to identify here is when does a re-render happen, right? So let's try to visualize a little bit what we have discussed so far, and let's see about whether, or maybe we will remove this pretty console. I'm not so sure. Let's see. I'm just experimenting here as well. Let's try to create a little DOM, and this is going to be a counter for us. So it's just a counter example. We're going to have some counter here that is going to be printed in a display counter. And all I'm going to receive here is the counter, right? Actually, whenever you're working with TypeScript, then you have a function component, and this function component is going to receive the counter as its its props. So here I can access directly the counter, and maybe I can just put this in a new line like so. And now here all I can do is just return, let's say, h3 with the counter, h3, right? Oops, wrong side. There you go. And now here we can display the counter. And we're going to simply say counter is equal to 0 for now. We're going to add the logic here to manage the counter. Now this here we have the parent re-rendered, and I would like to print here pretty console counter re-rendered. And maybe I just want to pass a default value, because if I don't pass anything, I'll just say here equals 0. So now it doesn't, now it doesn't complain. Perfect. So let's have a look now what's going to be displayed. I'm going to refresh this, and you will see that we have a counter re-rendered, child component, and then we have all this here that we can get rid of them. Okay. And here I can just say pretty console, so that we have everything at the same level. Perfect. So now let's try to understand what happens. So basically what happens when I change the props here, right? So instead of having a 0, I'm going to have something a little bit more dynamic, and I'm going to use useState. So I'm going to have counter here, and then set counter. Oops. Then set counter, and for this I'm going to use a useState. Now the useState is going to receive 0 as its starting state, and I will just pass the counter here. Or even better, I'm gonna actually give you an example of what you should not do. What you should not do in React is let counter equals 0, and then we're going to do an on click here, and the on click will simply say counter equals 1. Okay, let's have a look at the impact of this, and for that we actually need another component. I mean, we don't need a component, we could actually just use a button, it's fine. So instead of the child component here, I'm just going to use a button, or actually let's leave the child component here, and I'm going to put another button here, right? Button, and we're going to have increment, that's super typical. There you go. And then the onClick here, onClick is going to simply call the onClick function that we have defined above. Okay? So let's have a look. What do you think is going to happen when you click on this button, right? We have a button here, increment. Let's try to think about it in different ways. First one is, will the 0 here, and actually let me have a pretty console here as well. And the pretty console is just going to say child component re-rendered. Okay, perfect. So I'm going to clear everything. I'm going to refresh the page. There you go. So we have the first, right? Parent re-render, then we come directly to the counter re-render, which is from the display counter, and then we have the child component re-rendered that comes from here. Okay. What we are now interested in figuring out is this a valid construct in React? Will this update triggered by this button increment here, is this going to do anything? And you could argue yes, because it's going to change my counter, right? So therefore, you told me before here that a change in the component's props is going to trigger a re-render. Let's see what happens. Oops, nothing happens, right? It's hard for me to fake a surprise look because I know that nothing's going to happen. So anyway, if you're surprised, the idea here is that there is no, this does not characterize a state for React, okay? For us to have a state in React, we need to have another construct that React uses, which is called a useState. Just a variable does not trigger a re-render of a component. React is not gonna re-render the whole thing, because a render here, React doesn't really keep track of this variable to identify, oh, this value changed here. It doesn't matter. However, if I were to put pretty console here and say counter, right? Now what's gonna happen here, and I do need to have it to string, I think, because it should be a string, right? So let me refresh this. And if I click here, you see that the value actually changes. It changes in the variable, but it doesn't trigger a re-render. So let's fix that. And to do that, we actually need to use a little piece of state called useState from React. Now this allows us, and this gives React the sign, the indication, look, keep track of this little value, and whenever it changes, trigger a re-render, please. Okay, so we're going to have our counter here, and then we're going to have set counter. What useState returns to us is really two methods, or actually one method and one variable. The first one has the value that we want to track, and the second one is a method to update it. So now my counter is going to have the state of 0 to begin with, and then whenever I click on this, I'm going to call set counter to counter plus plus. Okay. And why is this complaining? Because I have to indicate number here. What is it? Cannot assign to counter because counter is a constant. What's up? That shouldn't be the case. let me refresh this because it should be working. Okay, let's have a look at what happens here. That's interesting. So this is working, but why isn't it working before? I think it tries to do some assignment to the aha, yeah, of course. Okay, counter plus +1 maybe, like so, right? Oops, sorry. Yeah, little brain moment. Yeah, that should solve the problem. There you go. Cool. Yeah, sorry for that, but happens. Let's have a look at the console log, right? I'm gonna clear everything. I'm gonna click it again, and you see how many re-renders actually happen. So the only thing that's really changing in the DOM is the number, but you see that the parent re-render changes, or the parent gets re-rendered because it's changing its state. Now, because the props of the display counter change, and because it's a child of actually, I think it depends, right? Here are two cases happening together because the props change, and because it is a child of the app component here, it also re-renders, but also the child component re-renders because it is a child of this component. So you see that there are many things that can trigger a re-render, and if we had like deeply nested things happening here, let's maybe try to create a list, right? And here we could make a const list children or children component, right? Children component, and all this is going to do is going to have a little huge list is equal to 1 2 3 4 5 6 7 8 9, right? And then we're going to just return a React fragment like so, because we need to return only one element at the topmost level, and we're going to say list.map, and for each element of the list we'll simply return, actually we could even do it without the element, we'll just return a child component like so. And I'm missing a key, so I'm just going to use the element for that. So key is equal to the element, right? Is this happy? What's up with this? Child component was used before it was declared, so let's just move things around. There you go. Now it should be happy. And here we're going to have children component, right? So now I'm going to save. And the child component could actually receive here just a number, or maybe it doesn't matter. I mean, it's really hard to see the 9 here, so I'm just gonna copy this, and I'm gonna say that this is gonna be our child number, right? And then another way that you could use it, instead of destructuring directly here, you could say props, and here I'm just gonna change this to use the backticks, child $ props dot child number re-rendered, and here I need to pass again the child number, and this is going to be the element like so. Now it should be fine. There you go, you got all the things, all the elements here rendered on the screen, and you can see that we have the parent re-rendered, the counter re-rendered, and 9 children re-rendered. If I press the button again, we have parent re-rendered, counter re-rendered, and the 9 children re-rendered. Now let's do something fun, and we're gonna add a little bit of delay here, and I think I actually need to change the settings here. I don't know how to do that, but I'm gonna do it anyway. So const now is equal to date. This will probably give a warning for me, and I'll fix this in a bit, okay? So while date dot now minus now is less than 200, what I'm doing here is I'm adding a 200 delay, right? Just gonna save this, and let's have a look here. While date dot now is different than now, and probably I triggered some infinite loop. Why isn't this allowing me to actually, because it is re-rendering everything, and then because it is re-rendering everything, we are entering into an infinite loop. Okay, that's interesting. I'm gonna remove this now. And welcome to the world of React. Sometimes you have some very interesting little infinite loops that come out of nowhere. Not come out of nowhere, but here they come out of the fact that things are being re-rendered, and then whenever you re-render something, then it can enter into this infinite loops. Let me have a look here. I'm just gonna refresh this. It doesn't work. Can I stop this? No. That's very interesting. I think that maybe I need to refresh the page. Let's copy the code and let's save this and just make sure that I can refresh the page. That's very nice. You'll come across this quite often. Don't worry about it. Give it a couple of seconds. I think I broke the whole application. Let's see. Can I start a new sandbox? Okay, that's very interesting to me. Never happened to me before, but here is working. Why isn't this working? Let's try again with the code sandbox like so. Okay, cool. I broke everything. Okay, let's do it like this. Let's take 5. Let's have a 5-minute break. We're gonna come back at around yeah. There we go. It's back. Okay, cool. Sorry for that. Let me see if I can go back to my little code sandbox. We are not gonna take 5 minutes, right? Okay. Now here is my console. And it didn't like that I added that infinite loop, and actually had some very bad consequences. So I'm thinking about how can I cause a delay here. Let me see. JavaScript promise sleep or delay, right? This gonna give me some nice functions. Just a little snippet. There you go. And we have it here. I'm going to call it delay with the milliseconds. It's going to be a number. And then here we need to have this is going to be an async. I don't think I can actually use the async here. No, I cannot use the async. So I give up on the delay. I give up on the delay. I have to give up on this and give up on this. How can I run some expensive computation? Let's see. Run expensive computation, JavaScript. Code snippet. Expensive. I could make a loop, right? Let's see if this is gonna work. And this is a number. What is this? Left side must be of any number big int dot get time. New date dot get time. Let's see if that works. It would be nice. If it doesn't, then is that the number of seconds? So let me see if this is gonna break everything again. If this breaks everything again, then we're gonna take 5 minutes and then we'll be back. Okay. That is an infinite loop. Okay, that's what I wanted to see. By creating a sandbox.config.json file. So this I should be able to add here. Sandbox.config.json file, open in file editor, infinite loop protection false. And there you go. So now I'm just gonna refresh, and as you can see here, so everything is working on the side. Let me deliver a little smaller delay of 0.1 seconds. Okay. And as you can see, my browser is completely broken. There you go. It is there. But as you can see, my browser is completely broken. And why is it so? Why is it so that the browser is completely broken? Let me try to refresh this. It's also everything is going nuts. And the problem here is that the re-renders that allows me to answer my final question. Are too many re-renders bad? So here I'm gonna stop. Everything went bananas. Let me remove. No, everything went bananas. Go. Bye. So re-renders become a problem whenever they have long-running operations. Okay. Here, as you can see, and it's back. So let me see if I can give you the example again. I still didn't give up on this. Let me remove this. Problems, wait is defined but never used. That's fine. And let me try to re-render this. Okay, so it's here. I'm gonna reduce a little bit the length of the list, and I'll just have weight 0.1 here. Let's see if that's gonna work. Okay, yes, this works fine. So now I think I can finally demonstrate this stuff. A re-render becomes expensive whenever it starts getting slow, whenever it starts computing some things or running some functions that require some computation time, okay? Here, as you can see, I'm gonna click very quickly on the increment, and as you can see, my application is getting really blocked, like it's not really smooth, right? And here I have only two components. If I increase this time a little bit from 0.1 to let's say 0.5, then let's see what I get. And now you see that things are taking even longer. Now, whenever I click on the button, then it's taking a lot of time to actually perform this application, and the UI is completely blocked. I cannot select anything. I cannot click on the button. It's horrible, okay? Then only at the end, I can actually execute some functions here, or I can actually go back to interact with the UI. So the way to make re-renders in React cheap is by not running any computation or any expensive computation on the UI thread. What is the UI thread? Basically everything that is running in your React application. Any type of JavaScript code that is running in your React components, in the files, will be run on the JavaScript UI thread, which is because JavaScript is single-threaded, and that will actually cause the components to rerun these expensive operations every time that they get re-rendered. Now let me move this wait application a little bit over here. So now I'm gonna simply put this in the counter, and the counter, let's say the counter here, we'll see that it's not going to make that much of a it's not going to have the same impact as the children component, because the counter would take this delay only once, right? So I'm going to put 0.1 again, and I'm going to click on the increment, and you see that is relatively, it's better than the previous one, even though it's still 0.1 delay, but it feels more responsive. Now here I'm running this long running operation just once. If I move to 0.5, you see that it still takes time, and if I click multiple times, it still blocks the whole UI. So bottom line is, what I want you to bring with you is, too many re-renders are bad whenever you start running too many functions, too many operations in these re-renders or in these React components. If you're running some, I don't know, expensive calculations, or if you have too many components and each one of them takes 0.1 seconds to render, then if you think about it, if it takes 0.1 seconds, that's 100 milliseconds. It's not that unrealistic. But if you have 100 of these components, then that would take 10 seconds, right? So it's a lot of time, and it's definitely something that web applications cannot afford nowadays, to be responsive for such a long time. Okay, so we dug a little bit deeper actually, and we did quite a few things here. Let's take 5 minutes, and when we're back, we're going to talk about the life cycle of a React component, as well as evaluating here how does the useState hook works, and the few things that we need to keep in mind when working with React components and React state from now on. Okay, let's take 5 minutes and we'll be back at 7:25. So see you there. Hello and welcome back. So let's go to the second part of this discussion, and we will talk about the life cycle of a React component. As we discussed before, and I erased it from here actually, so apologies for that, but whenever a new component is rendered, it is introduced to the DOM. What we call it is the mounting of a component. Here is one example that we can try to really mount a component on the screen. So just gonna erase everything here. Let's remove the things that we don't need. Let's do a little bit of cleanup. And what I want to do here is I want to write some conditional text. Okay, so I'm gonna say this hello code sandbox here. We'll extract this to another component. I'm just gonna say const title. And this will be exactly what we had before. So nothing magic here. I'll copy this, paste it here. And I'm not sharing my screen. Damn. There you go. Okay. Should I redo everything? Maybe, right? Okay. Undo. This is streaming. I cannot undo what I said, so apologies for that. Anyway. At least I realized early enough. So let's talk about the second part here, the lifecycle of a React component. And I was sharing this thing that I erased, so I'm sorry for that, but let's continue. Yeah, I'm gonna delete a few things. So as I said, I will remove the children component. I don't need this anymore. And I'm gonna delete it from here as well. Okay. Let's understand now what is the mounting, unmounting, and so on and so forth. And all I'm going to do is I'll just extract this to a component called title. So const here title is equal to a component that returns that header. Now here I'm going to say I'm greater than 5. Okay, and this will be rendered conditionally in the DOM. And let me just do a little bit of a change here because I want to see when exactly this is going to be printed on the screen. I'll return this and I will pretty console title re-rendered. So there you go. We got our parent title and then counter. And what we're going to do is we will say we'll have the increment button, we'll have the decrement button now, decrement, and here we will have increment, increment, there you go, and we will have const decrement, and decrement, I think that's how you say it. Decrement will simply subtract 1 from the component, right? And here we will decrement. So let's see if this is working. Increment, nice, decrement, nice. So now I would like to print this conditionally on the fact that our counter is actually greater than 5 or not. One way that many developers do is they wrap this around curly brackets and say counter greater than 5. And like so. This makes sense, right? So here you see that we have 2. Once we reach 5 and we go above that threshold, then we have greater than 5. Now let's clear the console a little bit. I'm gonna hide this, and as you can see, once I increment, I don't render this component because it's not in the DOM. I will continue incrementing it, and then once I reach the 6, then you will see that the title re-rendered is printed here at the bottom. Okay, cool. So what happens once we mount this component into the DOM once the counter goes beyond or goes above 5? There are 3 key, or actually 2 key moments here in React that you would like to keep in mind. The first one is the mounting in the DOM. And for that, we can identify whenever the component is mounted by using this weird looking syntax here of our useEffect. And this useEffect has the following shape. The first argument, it receives a function to run. And the second argument, it receives a list of dependencies. Now, for React, this is how you would, for example, execute a function whenever a certain state has changed, because the state would then come here as a dependency, and this function would be run every time that the state changes. This, when you don't pass any dependency here, this signals to React that this function should be executed whenever the component is rendered into the DOM. Let me have a look here. Let me see, I think it's like this. And I'm gonna try to increment, and here we'll pretty console mount it. Okay, and I'm gonna increment it once again and once again. You will see that we have our mounted here. If I increment once again, oops, you see that it's still here, but that shouldn't be here. That's interesting. Maybe I'm messing things up here, but let me have a look. Let's see, mounted. Okay, now it's gone. Yeah. So when you, sorry for that little mistake from my side, when you pass an empty array of dependencies, and now it's interesting. So I'm gonna refresh this whole thing, and I will increment, and here I'm at the boundary. Now, once I click on this once again, you see that I have the I'm greater than 5 here printed on the screen, and I have the mounted here at the bottom. Now, what this does is it executes this function only once, only when the component is introduced to the DOM, okay? This is, for example, a good place for you to do some data fetching for the component, because then you trigger the API call only once, and then it fetches the data. You can continue with your rendering, and then whenever you have the data, then it will update your component. If I click on increment again, you see that this function here is not really re-triggered. It doesn't trigger this function every time that we run a re-render of the component. Even though we print the title re-rendered, this we still print every time. We don't print the mounted every time. Okay. Now, what would happen if I were to decrement until this component disappears, and then I click on increment again, and you see that the mounted is back here on the screen. So imagine that you were doing some data fetching, for example, and in this data fetching, you were getting some data and storing it in the cache. And you would like to hide this component conditionally, but then when you show this component again, you wouldn't like to do this data fetching again. And the problem, or the solution to this, is actually in here. You wouldn't want to really hide, or you wouldn't want to remove this component from the DOM conditionally. What this is doing, what this line is doing, is it is dynamically adding and removing a component from the DOM, from the both React virtual DOM and from the actual DOM. Now for React, when you do such an operation, when you completely remove the component from the DOM, this leads to a few things. First, it's gonna run all the functions that you pass for it to run when you unmount a component. We'll see that in a bit. Second one is when you add them again, it will run all the functions and all the life cycle again of mounting the component to the DOM. And the third thing is that whatever state you have in here, it will simply be deleted and be reset. So let's have a look. We're gonna try something here. We'll have a state, right? Use state, and I am greater than 5, and here let's put some exclamation dots, and we will say print exclamation, set print, oh sorry, not exclamation but question mark, print question, right? And then here we'll say set print question, and then here we will say I am greater than 5, and if it is print question, we will actually here I should say just question flag, right? Question flag set, sorry for that, question flag, just realized that I made a little mistake here. This should be a false or true for that matter. So if question flag, then we'll simply print 2 question marks, otherwise we'll print an exclamation dot. Okay, so let's have a look. Now we are printing things here with the question with the question marks, and then we know that we can use the useEffect to run a function for us whenever the component mounts. So I'm going to print out this pretty console, but the other thing I'm going to do is I'm going to set a timeout, set timeout, and then I simply want to do set question flag to false after, let's say, 1000 milliseconds. So what this will do is after 1000 milliseconds, that when this component is shown at the DOM, it is mounted, it will change from the question mark to the exclamation dots. Okay, so let's see, question mark, and then boom, exclamation dots. Now, you know that when we unmount a component from the DOM, or when we do some certain operation like this, that the component gets completely removed from the DOM and then it gets added again at a later point in time, we will completely remove all the state that we have, and React will treat this as a brand new component. So if I were to decrement this component and then increment it again, or the counter, right, decrement the counter and increment it again, what would happen to my question marks here, or to my exclamation marks here? Will they be directly shown, or will I still show some question marks? And let's have a look. We have the question marks again, right? We have the question marks again, and we have the question marks again, and it doesn't really matter, we have the question marks again, but then again, if I continue incrementing, then they don't come back. Now, this is really bad, right? This is really bad. Imagine that this was a form component, that you have some state or something, and you use some collapse button to show some fields conditionally. If you completely remove them from the DOM, you lose all the state you have. Imagine you are storing the state of this form into some useState variables. If you remove this component, you lose everything. You're not able to persist state, except if you use some other fancy stuff, but you're not able to persist this state using simple useState methods. So just be careful with that, because it's a pattern that I have observed many times, that we render something conditionally to the DOM, and then we lose eventually the realization that whenever we remove this from the DOM and add it again, then it's going to be a fresh new component, and whatever state it had within itself, it's going to be lost. So last but not least, let's then have a look at the unmount function. And the unmount function we can actually run by returning something from this useEffect. And I'm going to pretty console again with unmounted, right? So I save this and, oops, unmount it like so. I'm going to refresh it and nothing's printing, so unmounted is not being printed. Once I reach 5 here, I print the mounted. Title got re-rendered. That is another nice example here. After 1 second, only this component got re-rendered, nothing else. If I increment again, then we see that parent, title, and counter. Increment again, and now if I decrement, and then decrement once again, we run the unmounted function, or this return function, whenever we unmount the component from the DOM. So this would be used, for example, if you set any listener, or if you set an interval here, for example, instead of timeout, let's say that you set an interval, right? If you set an interval to set the question flag to not question flag. So I'm just gonna do a little bit of, this is actually, and then you see here, this is one example where I would have to pass this as a dependency to get to address some rules of hooks. We are not going to worry too much about it now, but let's have a look at what happens once I have it here. So this should actually change every second, right? But as you can see, this doesn't really work, and that's very interesting, because here we need to pass this function here, or we need to pass this variable so that it can update. So now you see that every second it actually changes, and you see that a lot of things are being run here. Hopefully this gives you one example of how tricky it is to actually and Can you see what's happening? That's really cool. I really like this example because it's a really bad example. And I should somehow stop this, right? How do I do it? Because I think that maybe like this. Can I refresh this? Is it gonna break? Let's see. So what was happening here is very interesting, is that we were not cleaning anything when we were returning. You saw that the counter started to go crazy, started to flip around very fast. And that is because every time the component got mounted into the DOM, it created an interval. And this interval was never cleaned. So what we should actually do is, whenever we return from this, we should, it's still running. Oh, there's a lot of printed stuff. Let me see if I can refresh this. So the idea is that whenever we return from this component, we should run some functions to actually clean the state of the component. If we have any intervals that we created, if we have any listeners that we have added, we have to make sure that we clean them whenever we unmount the component. Okay, if we don't do that, then the behavior that you saw here is actually going to happen to you as well. And you see it's still printing, and it's going very happy here, printing a lot of stuff. Let me see if I can close this. And I think it's the 4th or 5th time, I don't know, but it's a good example. Give it a couple of seconds. If you do have any questions, meanwhile, you can write in chat. If you don't have any questions, then I'm glad. I mean, I think that some of the explanation was actually quite deep at this point, or a bit confusing. If there's anything that's not clear, then just let me know in the chat. I'm happy to answer. Let's see, it's back, finally. Cool, so we have here, and what we will actually do is we'll just have an interval ID. Okay, and this interval ID, I'll just set this at 0. And here I think that it's called a clear. So just gonna, again, print this out. And here I'm gonna clear interval. And this interval is gonna be the interval ID. Okay, so whenever I unmount something from the DOM, I'm gonna remove this interval. And now I can safely say set interval. And this is gonna be set question flag to no question flag. Okay, now this is safe. Let's have a look at the console. I'm just going to clear everything up for us. I'm going to refresh this. I'm going to increment until we have 6, and oops, it's still probably from before. Okay, well, I don't think I'm going to actually manage to genius, right? I think I'm missing some parameter here. I'm sorry. Let's see. Okay, so it's still working, and that should be it's not from before. It's my fault that it's missing a little parameter here. Once I increment, that should be actually, now it's probably from before. Yes, now it's from before. Okay, I'm blowing everything up, and I think you don't need to see me fixing stuff around, but hopefully I managed to make myself clear. Let's again try to close this and try to open it again. Okay, last attempt, and then I promise I'm done. Clear. Now I've got my 1000 milliseconds here. So now I'm going to run this function every second, and this is my interval ID. And then let's have a look if that will work. Perfect. Okay, so now as you can see, it's actually then being executed here. Interestingly enough, I'm also printing out unmounted, and that's probably because of the changes that are happening here. Once I decrement, then it's okay. My component is not going crazy. If I edit again, it's also not starting to print a lot of stuff on the screen. You see that it's very consistent now because I'm able to clear the interval every time that I unmount the component from the DOM. It doesn't have anything, doesn't really stay within, or it doesn't keep this interval registered, right? So now it's much more predictable. That's actually what we would like to have. Now, another interesting thing is that I'm not sure why it's printing the unmounted here as well. That's interesting for me. If you have any explanation, I'm happy to hear in the comments. Otherwise, I will try to figure it out myself, but I cannot promise I will answer because I don't know if I'll remember it. The point is that also many times, or quite a few, and it's probably being printed because I have a dependency on the question flag. If I were to change things a little bit, let's see, useEffect, like so, and here I'm just gonna pretty console the mounted. Oops. So here I'm just gonna pretty console the mounted, and I have no dependencies, like so. And you can have multiple useEffects, okay? That's not a problem. Now here that should be correct. So now you see that the mounted is not always printed, and I'm gonna split up the unmounted as well. And here I'm gonna set a useEffect, which will have a function that returns a function that pretty consoles the unmounted. Also, no dependencies. And there you go. We got rid of those prints that we didn't like. Okay, now we know that it was within these dependencies here, and this was because of this dependency that it was causing these reruns. We can also use this here. So I'm just gonna remove this, and we can return this from this function. So if I were to just have it like so, and then return my function to pretty console unmounted, I'll refresh this, and let's increment, and there you go. We got the mounted, but then we are only reprinting the title re-rendered. We are not falling into the trap of always running this. Once we decrement, then we print the unmounted. Very clean, right? That's exactly what we wanted to achieve. To be honest, I was a bit surprised by the behavior here, but it makes sense, right? Here we indicate that this hook should be run, or this function here should be run every time the question flag value changes. The question flag value changes every second, which means this gets to be run every second, right? If we want to have a hook, if we want to hook into the mount stage or the mount lifecycle moment of this component, then we should use the useEffect hook without any dependencies. And then we can return a function from here that will be run when the component gets unmounted. Let's try it again. Mounted, there you go. Couple of title re-rendered here. Once we decrement, it also gets unmounted. It's fine to have multiple useEffect functions, and this is exactly the purpose, or this is exactly the situation where you would want to use them. Okay, awesome. So hopefully by now you are either super confused or you got the explanation you needed about how React works and what it means to have all these re-renders and lifecycle methods and so on and so forth. Also, as you can see, these things are not super trivial to identify. So it's totally fine if you're starting with React to get into some trouble with them. Don't beat yourself up if things don't work the first time, if you run into infinite loops and stuff. We've run here together into infinite loops. It can happen, okay? Most importantly is that whenever you are developing a component or a set of components in React, you try to understand when these components are being rendered, when they are being re-rendered, and what is happening, for example, or the pitfalls, the disadvantages of using such a pattern of conditionally rendering components on the screen. Another way for you to render this on the screen, so just display this on the screen conditionally, and here I think I will just really be super quick because I'm just finishing this. I will just pass a prop here, show, and that's going to be a Boolean, right? Props. So I will actually destruct this show. And then I will pass a style here. Style. And show, if there is a show component, I will have an empty one. Otherwise, I will have one with the visibility of hidden. Let's have a look at what's going to happen here. And now I'm not going to render this conditionally, but I'll simply say show is equal to counter greater than 5. Okay, you see that it doesn't show on the screen, and there is the empty space here, but as you can see, the component is actually in the DOM. It's going on, it's doing something, right? And if I were to increment it, then you see that we have it shown here on the screen. Decrement is not shown on the screen. Once I increment it again, it's shown on the screen. But you see that the mounted and the unmounted, they are not printed now whenever I hide the component. That's because I'm not removing the component from the DOM. I'm just hiding it with CSS. So these are two ways, right? Of course, this one here is a little bit more tricky because you need to really hide the component. Probably you would use a display of none here. I'm not so sure, but let's see. Yeah, exactly. And then when you increment and you decrement, then you would really just completely hide the component if you don't want to show it. Now, as you can see, this keeps printing if the component, whether the component is on or not, or showing or not. Anyway, I'm just sharing some of the things I came across in the past when I was working on such things, and they were very curious to me. Hope they were helpful to you. So I think that's it, actually. We can stop for now. We have discussed quite a few things here, the life cycle, the model of the React component, and hopefully by now you have a better understanding of how React works behind the scenes and how you can leverage this to develop better React components and React applications. Thank you for your time. Wish you have a great weekend, and I'll see you next week. Bye-bye.